C program to obtain the roots of quadratic equation. So the general quadratic equation is x square plus bx plus c equal to 0. Okay. Now this quadratic equation has or have three types of the root. First is real and distinct. Next, second is real and equal, and last real and complex. That is complex roots, not real. Complex root, complex roots. Okay. So this depends on the sign of b square minus ac. So discriminant, we call it is discriminant. Delta is equal to b square minus 4ac. So here in this case, okay, I am writing this. Okay, so what is your delta? The value of delta is, our discriminant is delta is equal to b square minus 4ac. For a real and distinct, the value of delta is greater than 0. For real and equal, the value of delta is equal to 0, and for complex root, the discriminant is less than 0. And we can obtain the root by using roots is equal to, or x is equal to minus b plus or minus under root of b square minus 4ac divided by twice a. So this is the formula to obtain the roots of the quadratic equation. So for example, so what is mean by root? If we substitute the value of x here, you will get LHS is equal to RHS. So for example, if we consider simple example here, first example for real and distinct. So consider x square minus 5x plus 6 is equal to 0. So if you compare with ax square plus bx plus c equal to 0, then a is equal to 1, b is equal to minus 5, and c is equal to 6. So the value of discriminant is equal to b square minus 4ac is equal to minus 5 square is 25, and minus 4ac is what? 24. So it is equal to 1, and which is greater than 0. So the what is the root here? So root is equal to x is equal to minus b plus or minus under root of b square minus 4ac divided by twice a. So x is equal to minus b, so this is equal to 5 plus or minus minus plus square root of 1 divided by twice a is 2. So x is equal to 5 plus or minus 1 divided by 2. So x is equal to 5 plus 1 divided by 2, and x is equal to 5 minus 1 divided by 2. So x is equal to 3, x is equal to 2. So these are the roots of the given quadratic equation, and they are real and distinct. What is meant by root? If you substitute this value of x here, you will get LHS is equal to RHS, that is 0 is equal to 0. So now in the second case, so this is the first case, the second case is real and equal. Here consider an example x square minus 4x plus 4 equal to 0. So again, if you compare this with ax square plus bx plus c equal to 0, then we get a is equal to 1, b is equal to minus 4, and c is equal to 4. So the value of x is, first we want to determine the discriminant, which is equal to b square minus 4ac. So b square is 16 and minus 4ac is also 16, so discriminant is equal to 0. And here the root r x is equal to minus b plus or minus b square minus 4ac divided by twice a. but since discriminant the value of this term is 0, so x is equal to minus b divided by twice a, so x is equal to minus minus plus divided by twice a, so it is 2, so x is equal to what, 2, and x is equal to 2. These are the two roots are real and equal. So if our discriminant is equal to 0, then we get discriminant is equal to 0, then roots are real and equal. In the last case, in the last example number 3 here, if roots are complex. Now consider an example, twice x square minus twice x square minus twice x plus 10 equal to 0. So if you compare this equation with x square plus bx plus c equal to 0, here a is 2, b is minus 2, and c is 10. So if you try to find discriminant, the b square minus 4ac, then b square is 4 minus 4ac is 4 times a is 2, c is 10. So this is equal to 4 minus, this is equal to 4 minus, it is equal to, sorry, here there is one correction, here is not 2, only x square minus, so a is 1, sorry, I am writing again. So here if you compare this way, then we get a is equal to 1, b is equal to minus 2, and c is equal to 10. So the value of discriminant is equal to b square minus 4ac is equal to b square, so it is 4 minus 4ac is 40, is what, 4ac is what, 4 into 10, 4 into 1 into 10. So this is equal to 4 minus 40, which is equal to minus 36, which is less than 0. So roots are complex. Here next we want to determine the value of x. Here x is equal to minus b divided by twice a, so minus b by minus b plus or minus under root of b square minus 4ac divided by twice a. So x is equal to minus b, so it is 2 plus or minus under root of minus 36 divided by twice a, so it is 2. So x is equal to 2 plus or minus under root of 36, so it is 6 iota divided by 2. What is here? Iota is equal to square root of minus 1. Since roots are complex, so x is equal to 1 plus 3i, and x is equal to 1 minus 3 iota. Okay, so the roots are complex roots. Now next, so hope you understood if the x square plus bx plus c is the given equation, then it has, the quadratic equation has 3 types of the root: real distinct, real equal, and complex root. Now in C program, first we are going to determine whether roots are real and distinct, real and equal, and real and imaginary root. So wide main, then first we are going to enter here, we are going to determine float roots. So first root value of a, b, c, and then a, b, c, then we are going to write a printf here, printf enter the value of a, b, c, and then we are going to enter this by using the scanf is equal to %f, then and a, and b, and c, and then by using the value of delta we are going to determine discriminant. So we are going to determine here disc or d. Okay, d only. So what is d here? D is equal to b square minus 4ac. Now if d is greater than 0, then we are going to print here, print the roots are real and distinct, and if the d is equal to 0, then print roots are print roots are real and equal else we are going to print here else roots are complex. Okay, so here I am going to write a C program. You can, okay, sorry, alt enter. Now include, we are going to include the header file, so include std io.h, then include conio.h, then void main. Now then we are going to declare a variable, so float a b c and d, a b c d, and then clear the previous output, and then we are going to display the message printf enter a, then scanf. We are going to enter separate value of a, b and c, so %f and a. Next time we are going to printf enter the value of b, coefficient b. Okay, and scanf %, since it is a floating point variable, and b, then printf enter c. Okay, then scanf f %f and c here. Okay, and c. So here we are going to okay, and then finally we are going to find the value of d, which is equal to b square, so b star b minus 4 star a star c. Okay, and then we are going to print here printf the value discriminant is equal to discriminant is equal to %f d. Okay, and then we are going to print here value get ch. First we are going to print the value, and then we are going to check the type of the roots of type of the quadratic equation. So statement missing semicolon here are the roots or the types of the root of the quadratic equation. So one root again, statement missing semicolon here also. So now if you run here, say if we enter the first equation, say a is 1, b is -5 and c is equal to, say c is equal to 6, discriminant 1 is correct. Discriminant 1 is what? Correct. You can check here. Okay, you can check what is the discriminant in the first case. Here in the first case discriminant is what? 1. Again, if you run one more times here, and if you enter the value, say 1 -4 and 4, in that case discriminant should be 0. Okay, now we are going to check now if d is equal to d is greater than 0. If d is greater than 0, then we are going to print f the roots are real and distinct. Okay, distinct. Distinct. Okay, okay, and else, let's say else if d is equal to 0, then in that case we are going to display here printf roots are equal. Okay, roots are equal. If or else if this is not the case, in the otherwise else we are going to display here printf roots are complex. Okay, so and now if you compile here, 0 error. And now if you enter here, say first time we enter 1, then -5, and then 6. So roots are real and distinct. Spelling is mistake. Roots are real and distinct. So I am writing a new line, and new line. Okay, now if you run one more times, say a is 1 minus 4 and 4. So roots are equal, real and equal. Roots are real and equal. So here is the real and equal. And now for complex root, if we enter here, a is 1, b is -2, and c is 10, the roots are complex since discriminant is -36. Now we are going to print root. For that we are going to enter here math library. So include math.h. Why? Because we want to determine here square root. For that we are going to enter here math.h. Now if roots are real and equal, so I am going to write here, for take two roots here, r1 r2. Define 2 r1 r2. So r1 is equal to minus b. So it is minus b minus b plus square root of d, square root sqrt of d, and divided by 2 star a. Okay, so now if you compile one more times, 3 errors, statement missing semicolon. Okay, more times. Okay, so r1 is what? Minus b plus, similarly what is r2 here? R2 is equal to minus b plus square root d divided by 2 star a, minus here, one time plus, one time minus. And now printf roots are say first root, say first root is equal to %f, and second root is equal to %f. Okay, so %f, first root is r1 and second root is what? r2. So now if you compile, 0 error. Now if you run here, say a is 1, b is -5, and c is 6. So the discriminated roots are real and distinct. First root is 2, second root is 3, but we want to write here new line. Correct, our program is correct. And now we are going to write the same for real and equal. So I am going to copy this, I am going to paste this, and then change here. Since it is square root is negative, there is no need to write this square root term. Why? Because d is 0, discriminant is what? 0, and square root of discriminant is what? Negative 0. So first root is r1 and second root is what? r2. Similarly, else and again I am going to paste here, edit, paste. So the first root is what? Minus time d. Since it is negative, we want to make it into positive, so minus minus become plus. And then first root is percent f times here real part. So now we are going to write here real and imaginary part separate. So real part is what? Minus b divided by twice a, and imaginary part is, so what we want to do here, okay, okay, r1 real and r1 imaginary. So r1 imaginary img, r1 real, r1 imaginary. Imaginary is what? sqrt minus d divided by 2 star a. So this is what? Imaginary 2 star a. And this is the real part of the first root. This is the real part of the first root, and this is what? Imaginary part of first root. Then similarly, for r2 real, here it is minus b square root of minus b divided by twice a, and r2 imaginary img is equal to minus here sqrt minus d. Since we want to make negative into positive, minus d divided by 2 star a. So now minus b divided by 2 star a, there is no need to write this sign. So now we want to define this 4 variable. Okay, want to define this 4 variable as r1 real, r1 imaginary, r2 real, and r2 imaginary. Okay, now if you compile here, one error, r2 is a sign that is never used. Okay, expected here, minus b, I am removing this. Okay, so now we want to define here the first root is percent f plus percent I times percent f. Okay, and the second root is percent f minus I times percent f. So r1 real, r1 imaginary. So here it is r1 real, r1 imaginary, then r2 real and r2 imaginary. So now we are going to run this, 0 error. Now if you run here, first we are going to enter the real and distinct roots. So r1 1 minus 5 and 6. Here roots are 3 and 2, correct. Now we are going to, roots are real and equal. So for that 1 minus 4 and 4. So roots are 2 and 2, real and equal. And last case, if we run here, the what is the example is 1 minus 2 and 10. Here roots are 1 plus 3i, and second root is 1 minus 3i, correct. The first root is what? 1 plus 3 iota, and the second root is what? 1 minus 3 iota. So this is what I am going to first we have evaluated here the real and imaginary part of real first root, and then real and imaginary part of second root. Okay, so I'm going to explain this here. Okay, I'm writing this example again. Say here, x square minus twice x plus 10 equal to 0. So if you compare with ax square plus bx plus c equal to 0, then a is equal to 1, b is equal to minus 2, and c is equal to 10. And if you find the value of discriminant, b square minus 4ac is equal to, so it is 4 minus 40, which is equal to minus 36, which is less than 0. So here it is less than 0. So what is the roots here? So the real part, the first real part of r1 is minus b divided by twice a. So what is minus b here? Minus minus plus 2 divided by 2, which is equal to 1. And what is imaginary part? Imaginary part of r1 is square root of minus d divided by twice a. So minus d, so square root of minus d is what? 36 divided by 2. So this is equal to 6 divided by 2 is equal to 3. So what is the root here? Real, that is 1 plus 3 times iota. 1 plus 3 times iota. And second root is what? The real r2 real part is minus b divided by twice a, which is equal to again 1. And r2 imaginary is minus square root of minus d divided by twice a, so it is equal to minus 3. So the root are the second root is 1 minus 3 iota. So this is the we use this logic to for C program to find the roots of if the roots are complex. So hope you understand this. I am going to again. So this is the first we include standard library, math library, then we define the variable a, b, c, d for discriminant r1, r2, real, imaginary part, enter a, b, c, then find the value of d, then we print the value of discriminant, and by using the next we have roots b is greater than 0, then roots are real and distinct, and then we print we find the value of r1, r2. Similarly, if d is equal to 0, then roots are real and equal, and the last case, if it is roots are complex. Roots are what? Complex. So this is the block for complex root. This is the block for real and equal part.